Welcome to Biology of Marine Mammals. I'm Dr. Leslie Williams, and this is the second lecture covering Odontocetes. In this lecture, we'll continue with our groups, and we'll cover belugas and narwhals, the sperm whale, and the paraphyletic group known as the river dolphins. Finally, we'll look at all 6 groups together, and we'll create a phylogeny, or a taxonomic tree, covering the Odontocetes. So let's get started. In a previous lecture, we looked at 3 groups. We looked at the true oceanic dolphins, we looked at the porpoises, and the beaked whale. In this lecture, we're going to continue where we left off by first looking at the belugas and the narwhals, which comprise one family. Then we'll look at the sperm whale, which is its own family. And finally, we'll look at the paraphyletic river dolphins. Let's start with the belugas and the narwhals. Both belugas and narwhals belong to the same family. They are the only 2 existing or extant species still alive that participate in that family. Both species inhabit the same area. They both inhabit polar waters of the northern hemisphere or around the Arctic Ocean, though some actually move a little bit farther south than that. And although they don't look similar superficially, they do have some shared characteristics, including the fact that they lack a dorsal fin altogether and that they have unfused necks, which is rather uncommon for cetaceans in general. And I actually want to talk about that a little bit more. In another lecture coming up, you're actually going to learn that most cetaceans have a fused neck, and that actually prevents the neck from wobbling from side to side like this while swimming, which if you're trying to plow through water, you want basically kind of a solid torpedo shape. And of all the different cetaceans, belugas and narwhals are really the only group to maintain a lot of neck flexibility. So clearly there must be some compelling reason to keep that neck flexibility. Otherwise, they lose too much energy trying to keep their neck still while moving forward in the water. So let's go ahead and actually take a look with the beluga body plan and see if we can figure out what's going on. In this picture here, we can actually see that neck flexibility very, very well. And as you can see here, here's the body plan, and you can see the necks moving forward and to the side, so very flexible neck there. Of course, belugas are famous for being the white whale. They are all white, which is an unusual color to be all white. They're rather large, they're fairly muscular, and they have a thick blubber layer, tough skin, and again, lack of a dorsal fin. Probably the thick blubber layer helps them tolerate the cold water. But the tough skin, the lack of a dorsal fin, and possibly the unfused neck could help them break through the ice. So if you live in ice-covered waters as a marine mammal, you still need to breathe, which means that you might need to actually break through some ice in order to create your own little ice hole to breathe from. So having tough skin, no dorsal fin to basically run up along the ice so that you can come up really close without the dorsal fin getting in the way, and an unfused neck may actually help you kind of put your head up a little bit and kick open the ice. So we don't really know if that's what these are used for, but certainly it would make sense. Also, they don't have any teeth that are really visible. They start with teeth, but the teeth actually wear down to the gum line in adults. And this is because they are suction feeders, and so the teeth are not needed for feeding. The narwhals have long held a place in our fantasies as being the unicorns of the sea. So narwhals, of course, are unique in that they have a tooth, or sometimes 2, that emerges as a very, very, very long tusk. So most narwhals, at least most male narwhals, have 2 teeth, and it is only the left tooth that actually emerges straight and becomes as long as 3 meters, creating a tusk. It is, however, possible to actually get a double tusk as shown in the picture on the right. So that's not too uncommon where both teeth emerge and you get a double tusked narwhal, though most are single tusked or unicorned. So these are sometimes called the unicorns of the sea. Now, because the females do not have this tusk, The tusk is obviously not necessary for life, and so it is thought that the tusks are actually used to help determine dominance patterns. In other words, which male is going to be the dominant male in the group, possibly for competition to female mates. And also very interesting, they have discovered some narwhals that look suspiciously like belugas. And this is very, very odd. They have very many beluga characteristics. And they interpret this evidence to suggest that narwhals may actually sometimes breed with belugas successfully and create a hybrid offspring. As we mentioned in a previous lecture, we talked about determining speciation and what is the actual definition of a species. Here's another example of why no one definition fits all. As we said, the most commonly accepted definition is that a species is considered to be delineated or distinct if they breed with each other and create viable offspring. But what if you get a narwhal and a beluga that mates and they create a narluga, some type of hybrid? Are they still considered separate species? Well, they certainly look different. They don't normally mate, so again, very difficult to apply that definition concretely. So there's another example of why that definition doesn't always hold up. Let's move on to the sperm whale, which is Physeter. So the sperm whale is unique. It's really the only existing species left in its family, and it's also the largest Odontocete. Most people just think of it as a whale and often erroneously group it with the baleen whales. So it's the largest Odontocete and the only existing species left in its family. Of course, sperm whales are very recognizable. They are not only large, with very reduced flippers, but they also have a very characteristic boxy head that contains the spermaceti organ. And early whalers thought that that contained sperm. When they would actually take the carcass and they would look at it, well, it looked a lot like sperm in that spermaceti organ, and so people named this the sperm whale due to copious amounts of quote-unquote sperm. We now know that the spermaceti organ has nothing to do with sexual reproduction and is most likely used in buoyancy. Now, the sperm whales are actually found almost everywhere. They are a truly cosmopolitan species, and that means that when you take a look at their distribution on the planet, they are found in all oceans. And they are also very deep divers, which allows them to ambush their favorite prey, which is giant squid. So sperm whales are best known for eating the very elusive giant squid. To get down to 2,000 meters to catch them, they have to be very deep divers. So let's actually turn to that special boxy apparatus, the spermaceti organ. Now, the spermaceti organ is very complex and its purpose is not totally known, but it is speculated and with reasonable evidence that the spermaceti organ is probably used in buoyancy. In other words, just like a scuba diver who inflates or reduces their vest to allow them to remain neutrally buoyant, sink, or float to the surface, these guys might be able to do something with that very, very, very large head filled with waxes and fats and other types of lipids in order to help them maintain buoyancy, which you might imagine would be needed if you're a deep diver and you're going to get down to 2,000 feet and then hang there as you wait for a giant squid to come by, and you only have a limited amount of air supply. You have to be able to get down there really quickly and without spending a lot of energy. So you would want to be negatively buoyant where you sink. Conversely, after you've captured your food, you're going to want to come up to the surface really fast. So you're going to want to change your buoyancy from negative buoyancy to positive buoyancy and come up very, very quickly. And it's postulated that the spermaceti organ is actually the organ that allows them to do that. And clearly, it doesn't seem to have any other purpose, and we can't think of how it might be involved in some type of sexual selection. So we postulate that the spermaceti organ must have some very, very, very great value to these animals. Otherwise, natural selection would reduce them because they're very large and they don't really seem to serve any other purpose. But we'll look at the spermaceti organ in a future lecture covering diving techniques. For now, let's come to our last group, which are the river dolphins. The river dolphins. There are four, now three, existent species of river dolphins. And the most common, or the easiest to find, are the Amazon river dolphins, which is why I have two pictures here of the Amazon river dolphins. Now, a river dolphin just means that you are living in some type of fresh water. So we collectively group them as river dolphins. It's really an ecological grouping because these species probably are not monophyletic. In fact, there's no evidence to suggest that they are, but rather that they are originally oceanic species that independently moved into fresh water, became adapted to living in fresh water, and didn't come back out into the ocean. And this probably happened, this invasion into fresh water, particularly rivers, probably happened multiple times over the evolution of the Odontocetes, and so we just call species that happen to live in the rivers river dolphins, although it says nothing about whether or not one river dolphin species is related to another. So this is really a paraphyletic group consisting of 4 different families, and we just call them the river dolphins because it's convenient. Now, that's not to say that the river dolphins don't share a lot of traits. They do, and it's probably due to convergent evolution. So if we take a look at some of the commonalities in their body plans, we'll find that they have reduced eyes. Their eyes are very small, and you can kind of see this in the upper left picture here, where you can see this is an Amazon river dolphin that's kind of poking its head out of the water, and you can barely see its eye, it's so small. In fact, 2 of the species are nearly blind, so eyesight clearly is not important. They also have very large flippers for their body size, which is evident on the bottom picture. And they have flexible bodies. They can move really easily and up and down pretty easy. So they're very dexterous in their body plan. And also they have a reduced dorsal fin. You can see the dorsal fin isn't nearly as pronounced as many dorsal fins are. It seems to be like somebody actually kind of smushed it down a little bit. And then, of course, their elongated snouts are quite evident. They have a very pronounced rostrum or beak. And all river dolphins show the same general body plan, which suggests that these are adaptations to a river environment. So let's actually think about these for a moment and what they might represent. In a river, you're very murky and shallow. And because it's murky and shallow, you probably need to be able to move very, very easily. In other words, you can't use the whole large body of water to make a big turn, for example. You got to be able to turn really quickly and in possibly a confined space. So that probably explains why they have flexible bodies, and large flippers would help them actually maneuver their bodies pretty easily to make those sharp turns. The reduced eyes are probably a result of the fact that they are in murky waters, so eyesight is not needed, and it seems that they rely almost strictly on echolocation to identify their prey. The elongated snouts actually are used to help them very quickly snatch fish that come by. The longer your snout, the better, or the longer the utensil you have to basically stake your fish with, so that's advantageous. And then finally, the reduced dorsal fin. Dorsal fins are often used as a stabilizer while you're swimming really fast. Since they're in little, shallow bodies of water, they probably don't swim that fast, and they probably don't need a stabilizer because they're in such shallow water. So those would be examples of convergent evolution. Now, the zoogeography of river dolphins, in other words, where river dolphins are located, they're all located actually in either South America or Asia, and because they're in close proximity to man, they are in great danger of habitat degradation and loss, which makes them critically threatened, if not endangered, and we recently lost the Chinese river dolphin due to these factors. All right, finally, we're going to very quickly go through the evolution of the Odontocetes. So we had the Mystocetes, then the sperm whale is probably the next on our list, followed by the beaked whales coming off there. And then we have our belugas and our narwhals. We have our Phocinidae or our porpoises, and then finally our true oceanic dolphins or the Delphinidae. Notice the river dolphins aren't on here because they are a paraphyletic group. And with that, I'll see you next time.